Okay. I heard you guys.
Hey.
Where's my flowers?
You look great.
What is my flowers?
In today's video, we are going to build a procedural flower system. Let's jump in. First of all, it is essential to not get overwhelmed by the complex structure. We will break the flower down into manageable, less complex parts and assemble all of them in the end. The overview of the steps we are going to take in the video are: creating the stem, we are going to build the blossoms, we will have a look at the magic behind flowers and their alignment, we will copy those blossoms and make them bloom over time. In the end, we will resolve their intersections with a Vellum solver. And voila, we will have a flower. We finally arrived in Houdini, and let's start by dropping down a geonode, and we name this thing flower. Let's dive inside. And for my stem, I want to start by drawing a little curve in here. So let's drop down a curve node. Let's switch the view to the front, and let's make a little S-curve here, like this. Hit enter to apply, and let's go back in our perspective mode. This thing might be a little small for my taste, so let's drop down a transform node. Let's say we scale this thing up by approximately 4. It's still very pointy and very sharp, so let's fix this by dropping down a resample node, and let's go for something quite small with the 3 polygons as subdivision curve. Cool. Let's apply our curve view attribute, so we have a value that runs from the first point from 0 and up to the last point, which gets 1, and all the stuff in between will be an interpolation of these values. The stem right now is quite flat, and I want to fix this and give it also a little bit of movement over time. So for this I will drop down a group by range to access our first point of this primitive. Let's get this out here. Let's say this will be our first point. We want to have the point. We want to select the first point, not the last one. And let's invert this range. So now we have this point selected. In order to make it wiggle over time, let's drop down a Vellum hair. Wire this in. We can actually leave everything as is. And let's go directly ahead and drop a Vellum solver. Wire everything in. Let's go ahead and in the forces tab, let's remove the gravity because we don't want the string to fall down. Inside we will add a pop wind, wired into the forces, and let's say we give it ever so slightly an amplitude, but a quite big swirl size. And let's simulate. And you can see we are dancing around a bit, but now everything is dancing. So let's go into our Vellum hair constraint, and we will go to the pinpoint, and we will select our first point and say this is permanently pinned. Hit play, and now the origin stays always the same, but the rest of our plant is wiggling in the wind. Cool. Let's put on a Vellum IO and cache this out. This will significantly speed up our process. Put your base name wherever you want it to be. This will be mine, and you can hit save to disk. That should be really quick. And we have a nice little animation. And of course you can tweak it to your liking by just coming in here, adding more forces or play around with those that we already set up. Let's go outside and let's have a look at the geometry spreadsheet, because this will be our root, if you want to say so, for our entire setup, and we have a ton of attributes in here, so we don't need all of them. Let's drop down an attribute delete. like this. And I want to make sure that I keep my curve view attribute here. So let's go in here and select curve view. And to be honest, the rest can be deleted. So I say delete non-selected, and I'm just left with curve view and my groups, which is perfect. Another thing that we might need is, let's drop down another resample node, tangent U attribute down here, but let's deselect everything because I don't want to resample it, because I'm quite happy with this distribution of points, but I want to generate this tangent U attribute and I want to misuse it a bit. I don't want to use it as is, but I want to use it as a normal. So if we come inside here now, you see our normal of the curve will always point from one point on the primitive to the next. And this gives this really following shape of those normals, which we want to leverage in a second. Then I would say we drop down a null and we call this out stem curve, which concludes our first section. Next up is our blossom. Therefore, I prepared already a little setup in here. So I modeled two states, a very small one and quite a big state of the blossom, which opened up. I plugged it into a blend shape and animated it over a span of 120 frames to open up. If you also want to build something like this, and you can be totally creative here and model your own blossoms. The most important thing is, you see it's quite a simple setup. We are like starting with a subdivided box where we blasted off one side, and then with a bunch of different poly extrudes, and I always just selected one edge here. I tried to get the base shape, subdivided it a bit, smoothed it out, and then I split the node graph. And for the small section, I transformed it quite a bit with soft transforms and another subdivide. And I went ahead and basically did the same for the opened state of the flower. And the only thing that you need to keep in mind here is that each of the sides, and you see I highlighted the nodes in yellow, which define the number of points, because this blend shape here needs to have the same amount of points as an input for the shape 1 and the next shape in order for it to deliver the best results. Once both sides match, it's the same point number, you can really seamlessly blend between the two states. Afterwards, assigned UVs to the biggest state here, put them into a UV layout, and then just copied over the UVs to my animation in order for them to stay in place and not jiggle around or like being recalculated in each and every step. Matched sized it to the origin here and attached a null object. Let's copy that and let's go back into our flower modeling. Let's already prepare our object merge node in here. Paste this in order for us to access this animation in a second. But we will need to do some vector magic in order to prepare our stem to copying all those blossoms over. So let's tackle this in the next step. To understand how our blossoms align, we will need to do a bit of studying. Imagine you're a plant and you want to grow your seeds. So you have this molecular machinery going on that builds seeds and pops them out. Then it turns and builds the next one. But now the question raises, what is the best angle to occupy the most space? In other words, what is the most efficient angle with the least gaps? It's called the golden angle, and it appears everywhere in nature. It derives from the golden ratio phi, approximately 1.618. If you take a full circle, 360 degrees, and divide it by phi squared, you will get 137.51 degrees. This angle has a fascinating property. When you keep rotating by it, the new points will never overlap. That's why in nature, leaves and petals spiral perfectly, without blocking each other's sunlight. The scientific term for this is Phyllotaxis, in case you want to give it a little Google afterwards. So let's jump into Houdini, and I will briefly explain you how we will align our blossoms along the stem. So for this I want to use a point warp on here, and let's call this vector magic. Wired in and highlighted. I will visualize our normals because this will become quite handy in a moment, the points as well, and let's dive inside. I will make a little bit more room here because now we are not working from top to bottom but from left to right, and I have my normals here, which are basically the tangent U attribute but mapped to the normal. What I want to do with that is I want to use a cross product in order for the normals to not follow the shape of the curve but stick perpendicular to this kind of curve shape. So let's maybe have a little recap what a cross product is. Back in your math class, I guess you should have learned that whenever you want to multiply two vectors, and let's call them A and B, new vector that is basically perpendicular to both A and B. And that's what we're going to use now. So let's drop down a parameter, and in here we will call this cross vector. So this would be our vector B in this example. Let's make this also a vector, and we can select whatever we want. We can use the X direction, the Z direction, or we use both of them if we're like a little bit undecisive here. Let's drop down a cross product in here, and we will just multiply this vector with our normal vector, and we can have a look. If I come in here and I say we just go into the Z direction, you can see that our vector is pointing into the X direction afterwards. And if we cross it just with the X vector, our normals will look into the Z direction. Okay, I will go for both of them again because then it's a bit more in between. Okay, but now all of them look in the same direction. And if you look at flowers, as we just learned in the beginning, everything is aligned according to the golden angle. So let's get this thing in here. Let's drop down another parameter, call this golden angle, and let's set this to our 137.518 degrees. It's a float attribute. And now we want to rotate each point by this angle. For this, we can access this point number here. Let's multiply each point with the golden angle. So the first one will be 0 because it's point number 0. The first one will be exactly the golden angle. The second one will be twice the golden angle, third, fourth, and so on up the chain. And now we need to rotate this vector according to this angle. And if we put down rotate, you see we have two options, and for this I want to use the rotate by quaternion. And this often scares people, but let me show you that's actually nothing to be scared of. Quaternion, and we will need one for that, as you see here in yellow. So let's drop down a quaternion, wire it in, and to take away your fear, you can basically memorize it like this. A quaternion is just a special way to describe how something rotates in 3D space. A quaternion stores a direction, like this axis you want to turn around, and the angle. Okay, so as a rotation, we want to use our normal. Remember, the normal was just following along the shape, which is perfect to then rotate our newly created cross vectors around. And in the other input, the angle, we will put our golden ratio. But before we do that, it would be actually good to remap this golden angle, because here we are working in degrees, and I think the quaternion in Houdini works with radians. So let's quickly convert this from degrees to radians, multiplying it by our point number, putting it into the quaternion, and rotate our cross vector by that quaternion, and then plug it into the normal. And then you see we rotated each and every vector around our base shape by the golden angle. And this results in this typical flower arrangement that you see all over nature. Perfect. One last thing I want to do, which later on will become quite handy. We are going to bind export our normal, because we override the normal here. So we still need to have this kind of tangent u attribute. Let's just call this up. This creates an up vector. Let me jump out and also visualize this one. That still runs along our path here. And once we copy over our blossoms, this will help orient them better. Let's save this and let's continue. Let's get rid of this visualization. So now that we have all of this, let's prepare our flower a little bit more. So the blossoms should not start here at the bottom. So let's give us some safe space down here, which will be just a stem. So remember, we already basically calculated our first point of the primitive. So we can use a group expand node like this, which we name bottom, and our base group will be the first point. Let's highlight it and let's increase the steps here to, let's say, 25. The next thing I want to do is I want to grow our plant over time, and for this we need an attribute that runs through here. It will drive the thickness of the stem, it will drive when our blossoms will grow and the size of those blossoms in a point wop like this. Let's call this create mask, and here we do it manually, but you can also use the mobs tools or like the pyro spread node, and yeah, remap the temperature to a mask attribute. But let's create it in a manual way, not too complicated. So let's bind our curve attribute in here, and we need two more parameters. We will need a position which goes from 0 to 1 like our curve, and we will need to have another one that is called width. Perfect. So now we will fit our curve to the destination minimum of whatever we put in at the width. So if it's like, let's say, smooth, of course our curve value should be always at the lowest point of this kind of smoothness, let's say. In the next step, let's add our position together with our width here in order for our width to follow our position. And let's use another fit range in here where this value here gets remapped to our position as the source minimum and our following along as the search maximum. Let's bind export this thing. Let's call this mask. Plug it in. Let's jump out, and we have these two sliders here. Let's get rid of the points, make it a little bit bigger, and let's visualize our mask attribute. So once I start pushing this slider up here, you see we will run through it, and once I put like something like 0.485 in here, you see we will make it very smooth, and we can vary it quite a lot. And this will be now something that we animate over time. And let's do this by holding Option, click in the first frame here, and let's say over 72 frames we want to arrive. Maybe not at 1, but at 0.9 maybe, or 0.8. Yeah, maybe 0.8, because we never want the top part of the flower also fully grown. So there should be like this kind of tapering shape of our blossoms going upwards. Cool. This is our mask attribute. And to put this to task, we can use another attribute delete just to keep this side of the path nice and clean. Let's delete everything but the mask, and let's rename this attribute from mask to p-scale, and let's use a sweep node because this will understand our p-scale attribute. And you see we are running from the wrong side, so maybe we attach an attribute remap. Before that, we want to use the mask as a mask. Somewhere in the middle, let's calculate the range. We want to use it from 0 to 1 and of course invert it. And now you see our sweep will understand the p-scale attribute and scale whatever we put in here by this amount. Let's give it some caps like a grid here, and let's maybe not make it completely 0 but 0.05. So there's always a little thickness, and let's also make this maybe half the size, which looks a bit better to my eye. And in the sweep, we can even come in here and tweak this further. Let's come in here, make this a B-spline, for example. Pull the tip down a little bit more even. Make it up here, make one in here. So like there's more this less linear approach to the growing, but a bit more organic shape. And this we can actually name out stem geo. And you see, it will grow with our mask. That's pretty cool. In here, we can of course construct some UVs and we're good to go. Let's save that. And now that we have our stem ready, let's copy over our blossoms. We wanna create a p-scale attribute. So our attribute adjust float. This is automatically set to p-scale. Let's say we want to ramp attribute. We want to use the curve u attribute here. Turn this around. This time we want to have a 0, 0.5 maybe. Let's make it a B-spline again. Let's do the same curve we had in our sweep node like this. And let's attribute combine this with our mask. So we use our destination as the p scale, and we want to multiply it with our mask attribute in order for it to grow. Let's use add sop because we are just interested in the points. So we say delete geometry but keep points. Let's put our normals and check if they are still there. Yes. And the blossoms should not start in the middle of the stem but like a little bit more outside. So let's use a peak sop like this. Let's put those points away from the stem along the normal by maybe 0.06. Yeah, that looks quite cool. If you look at our normals, they are gone. So let's uncheck recompute point normals. Yeah, that looks perfect to me. Points to copy to. And now it's time to come back and get our object merge with the blossom. We can just use a copy to points. In here, our target points will be our points, but everything but the bottom. So in our object here, and let's highlight it. And you see, we already have this kind of tapered shape around it, which grows over time. But all of our flower heads or blossom heads intersect quite a bit and are growing at the same speed, which we don't want. We want the ones at the bottom open up before, while the ones at the top still being very, very small and in their closed state. So how can we do this? And for this, there's a very simple and easy trick. So first of all, we need a kind of attribute that tells us in which point we are working on. So let's drop down a for each loop, but for each point. Let's put this in here. The output will be this one. We will need to create this metadata input node because this will create in our details here kind of iteration. So you see we will have 140 points in total. In our object merge, we want to attach a time shift node that goes in here. And usually it's used to freeze your animation to a certain point. But what we can also do is like offset the animation by our iteration number. So for this, let's come in here and let's say $f, which gives us the current frame number. And let's subtract our iteration. So it's on the detail and it's on the for each metadata 1 input node. We are interested in the iteration and we need to put a 0 down here. We can do it like this. You see this will result in a minus, but it will result in a different one for each and every iteration. And we can also come in here and we add a float, which we call offset, hit apply and accept. And we have another slider here. Let's put this to 1. Let's copy this parameter and let's paste relative reference. And let's just make sure we put these two things into the brackets. You saw already, if I come down here in my for each loop, highlight it and we play it back, you see everything is growing, but then the flowers start to blossom at the bottom and making their way up the entire shape of the flower, just by offsetting each and every point by the iteration number. You could also play around a bit with the offset, but I just leave it like this, which is pretty cool. And in the next step, we just need to fix our overlap. So how do we solve those intersections? For this, I want to use a Vellum solver again, where we pipe in our blossoms and then let the Vellum constraints do their job by solving those intersections. And I will need one point down here. Let's say this middle point, group it, and we will say this is our attach point, which will be then propagated through our system here, and we can access it in a second. Let's group it again, use the points, put in a star in this regular expression to really select all the points, and let's say pin. Let's branch this out to a new null object, and let's call this blend shape, because this is now this blend shape of all of our blossoms together, and we will reference this null, so let's copy it already in a second in our Vellum setup. In Vellum, I want to put down a Vellum configure cloth, and in here for the settings, I want to have a very small edge length scale, a stretch stiffness of, let's say, 10 and a bend stiffness of 0.001. These are the settings that worked good for me with the size of the flower, but you might fiddle around a bit with that. Next, I want to put on a Vellum constraints sub, wire everything in and set it not from distance, but to pin to target. As our target geometry, we want to use our points called pin. The thickness we want to set uniform to our edge length scale 0.02. The pin type should be soft, the orientation type should be soft, and we want to match the animation. And those stretch and bend stiffnesses will work differently than a normal constraint. So let's set this to 1 and 1. And what this 1 means is basically it follows completely the input, or tries to be as close to the points that we put in here as possible. And the value of 0 will tell the Vellum solver that it can go completely nuts and go fully Vellum. And everything in between will be a blend. So let's say like a 0.6 in here will mean 60% it should maintain its shape, but Vellum has 40% to do its thing. And maybe for the bend stiffness we give it 0.8 or something like this. So these two things are a little bit different from another. And let's drop down a Vellum solver at the end, highlight the solver, get rid of the gravity as usual, up the substeps to 2 maybe, and drop down the constraint iterations to 32. But you can also fiddle around with these settings a bit. Let's dive inside and let's use in here a rest blend. Wire it in, and we want to update it each frame. Now we introduced substeps, so we could also update it each and every substep. Maybe we do this for the bindings. We want to use a sub, and I hope I still have it in my clipboard, exactly this blend shape, and it will operate on the constraint geometry. As the constraint group, we want to set the bend and the stretch group to work on the right constraints. And now we can dive out and basically hit simulate. I will do this right away in a Vellum IO again, plug this in, change it to my location, and let's hit save to disk. This should take a brief moment, but hopefully not so long. So I will speed this process up and we see each other once this is done. Okay, now that this is finished, let's have a look at it. Yeah, you can see our blossoms, they will avoid each other here and here. Yeah, that looks quite cool. To further enhance this kind of thing, you can drop down a Vellum post process, wire all of them in. Let's give this some spatial blur with a nice little subdivision to have a little bit more things to work with. Yeah, okay, there's a little bit of defects here. Maybe we can introduce a little detangle. Yeah, that worked quite well. And let's maybe give all the flowers a little thickness here. 0.1 might be more than enough. Yeah, let's go with that. And let's tweak our setup a little bit more. Because right now, if we template the stem here, our flowers hang quite in the air. So of course we need a little cap down here. So we can come in here and say group promote. And I want to use my attach group. It was a single point, if you remember. I want to promote it to primitives. So here we created the point. It goes through our entire setup. And now we promoted it to primitives. And we can also say group expand again. We can use the same name, attach. The base group is also attach. And let's just grow this maybe 8 iterations. Let's blast this off. Delete the non-selected, like this. And let's maybe give this a little thickness. Labs thicken and very, very low value. Maybe both directions. 0.01. Somehow I have this little viewport bug here. Let's close the viewport and let's get this viewer back. Put it up here. It's better to judge our little area here. I guess this might be still a bit too thick. Yeah, maybe something like this. And let's use another subdivide node and attach a node and say this is out green petal. As well, just add a little bit more detail at the end. Yeah, cool. And now we need to connect this area to our stem, and for this blast away our attach group. Let's point this, and we of course want to delete the non-selected to be left with this little point. And let's get rid of all the attributes here. Delete the non-selected. Let's delete all the groups. And let's attach a point wrangle here. And I want to use a very simple expression, which is I at id equals at ptnum. Close it, so we create a little id attribute for each point, because this comes in handy in a second once I get this stem's curve and I object merge it down here. And what I want to do is I want to array those points back to our stem. So let's use a array sop. These points go onto this, and I want to say minimum distance, and now they snap into place again. I will merge those points with my original points, so now I have a matching point ID between the two, and I can just simply use an add sop in here, and then the polygons I can say instead of all the points I want to use by attribute, I say ID. And now we have a connection from each source point to the newly created one, which are then going to wiggle around and follow along. They're quite straight, so let's reshape in these kind of connections. Let's use another resample for that. Wired in, let's say 0.02. Yeah, that gives us quite some subdivisions to work with. Of course, view is always welcome, because this we can leverage in another point warp. Wired in. Dive inside and let's bind curve view attribute in here, and let's take our position and let's split it up. So vector to float, and then we use a float to vector again. And we want to use especially the y-axis to give it a little, maybe also a little S-curve here. Let's use a ramp parameter for our curve view attribute. And then let's multiply our y direction with our curve view. Let's pipe it in here and bring it back to the output. Of course, we did a little mistake. This ramp here should be a spline ramp. And once we crank this one up, put everything to 1, you see nothing changed. But once we expand this, make both a B-spline again, we say we add another point in here, which maybe is 1.01, and then we put another point in here, hangs down a bit, maybe 0.99, maybe a bit like this. So we have this little curve. You can basically model it however you like. Maybe let's resample this thing again. 0.002, 0.01, maybe, yeah, like this. Looks quite okay. Let's give this another sweep. Wired in. It's way too big for my tastes. Maybe go for this. Let's append a grid at the end again. And of course, let's scale this along curve to get an organic shape. I can start quite big to get this kind of sprouting root here, and then go a bit thinner. Maybe like this. Up here it looks a little bit too thick for me, so let's lower it like this. We can create a null and say out connections. And the last thing we need to do is basically attach a null here as well. Call this out blossoms. And now let's object merge everything together. So let's take our petals, let's take our blossom, let's take our connections and our stem. Merge it together and say null. Out flower. Perfect. Of course, we can come in here, also say compute UVs. We also need to compute UVs for our thing here. So let's do a labs auto UV very quick in here. And now we have our growing flower structure in here. I will render a quick flipbook for that. You modeled yourself quite a complex flower setup, and you can start playing around with this, changing the stem's curve, changing the blossoms, and you will be granted with endless varieties. I hope you found this tutorial useful, and we will see each other in the next one. Cheers and goodbye.